Good afternoon, everyone. I'm Mingyuan Ma from Griffith University, a PhD candidate. I would like to give a brief introduction to my PhD project. It's about hydrodynamic of marine aquaculture, especially for the hydroelastic interaction between ocean waves and offshore fish pens. This research is also supported by Professor Hong Zhang, Professor Dong Shenzhen, as well as Professor Mingyuan Ma. So, yeah. So, as we know, marine resource is an important supply chain of global food and prolification. Natural fish farming has become increasingly attractive, but could be cause serious environmental issues and conflicts over resource use. At offshore sites, there's a deep water column may reduce waste deposit concentration and give fish more living space for their welfare. However, the interaction mechanism of wave and flexible net structure exposed to high energy environment is well less understood. Therefore, our research objective is to investigate the wave responses of flexible fish pen structures, which include three sub-objects. Firstly, we would like to develop a fluid structure interaction analysis model for the flexible net cages. Secondly, we want to determine the characteristics of wave scattering or interference effects around the cages. Finally, we will conduct some parametric study on the mechanical properties for the fish pen design. Therefore, to achieve our research objective, our team developed a 3D hydroelectric modeling framework, AquaX. AquaX mainly includes some techniques between fluid mechanics and structural dynamics. The fluid dynamic solver is based on the perturbation theory, and the structural dynamic solver is based on the shell memory theory. Our model is feasible to do the strong coupling analysis between some semi-analytical techniques. And this model is applicable to arbitrary hydrodynamic conditions and fish pen designs. For the fluid structure analysis, we would like to build interference between the fluid solver and the structural solver to accurately and effectively simulate the wave responses. Herein, we model the fishing cage net as a flexible porous shell membrane. From our research simulation of our research, we can find that there is a weak-like wave attenuation pattern around the cage by the counterplotting of the wave amplitudes. In addition, significant wave effects occur at the location of the cage near the freewater surface, so it is necessary to design the fish farm in a submergible condition to avoid strong surface waves. Finally, due to the destructive interferences, the first order wave forces will be zero at some specific ratios of the cage diameter to the wavelengths. On the other hand, we aim to investigate the hydroelastic behavior of an array of fish cages with arbitrary layouts. But the wave interference phenomenon caused by the interaction of multiple cages are very complex. Herein, we use the Kagamoto and Yue interaction theory to determine the exact solution of the wave interference, and also the main drift wave loss could be determined using a near field method. Our model has been validated with studies of other research, and there is a very good agreement to prove our model is reasonable. Yeah, our simulation results indicated that the wave forces on the cage has the maximum peaks during the low frequency range of the waves. Also, significant shadowing effects of short wave amplitudes in the cage array cause different wave loss on those cages. For the implication of our studies, firstly, ArchiX is a powerful tool and important component in constructing digital twins of offshore aquaculture systems. Based on those research findings, engineering can better understand the hydroelastic behaviors of flexible fish pen structures and improve the design or layout of their fish farms. Our study also brings revolution changes to the aquaculture industry, providing producers with more reliable solutions. Currently, our research has published in several papers in the field of fluid mechanics and offshore engineering. So welcome to everyone to read them and give me some comments. It's very helpful to my future research. For my future research development, I would like to develop the solution for completed aquaculture systems. Also, more complex hydrodynamic phenomenon is very important when we design the offshore fish farming. Also, I would like to expand the scope of application of my model, such as offshore pile, wind farm. Finally, I want to couple the present solution with some data-driven models to prove the accuracy. Thank you so much.